Hello and welcome back to another video of Business Calculus, Math 1325, Section 11.4. We're doing curve sketching today. Now, I have a little note here. It says nothing new here. Try using Desmos graphing to help if possible. And let me tell you, Desmos graphing all the way today. Let me start you. I mean, literally, there's nothing new. It's everything we have been doing. Concavity. We've been doing domains. We're going to be doing vertical asymptotes. All this stuff that we've already known about. We're going to do it all today, and hopefully with Desmos graphing. So here we go. 11.4.23 is the first one I'm doing. And this one, as a warning, it has 10 parts. Yup. And the one after it, oh, I don't want to spoil it for you. It probably also has 10 parts. And then the next one after that has 10 parts. And the one after that. Oh, man. Yeah, this is a big one. This is going to be a big section. I have all the math done by hand on my notes. And that's good. I'm going to do that math by hand for you as well. At least on this one. Some of them I might skip just because it's that obvious in Desmos graphing. And so this is what it says, and it wants a whole ton of stuff. Before I even tell you what stuff they want, let's graph it. And this should actually be your very first step, always. Okay, so this is our graph. Okay, zooming out, that's our graph. And so we have this vertical asymptote. We have a horizontal asymptote. Don't really know where. It has a 0. There we go. There's a 0. It has a y-intercept. I mean, these things, we can at least pick apart some of these things. So the very first one, it says, Part A, find the domain. Now, the domain is, again, any values, x values that are possible. And I'm saying, do I have any division? Yes. So I need to take the bottom and set it equal to 0, solve for x. That's a hole. And so I need to go around this hole. And so that would be negative infinity up until 8, union 8 to infinity. And we're done with that. Basically, this vertical asymptote must be at 8. So let's do x equals 8. And yep, see, you can see it now. Cool. So let's keep going. Part B, it says, what is the y-intercept? We already found it. So that's my x, that's my y-intercept. Actually, I'm wrong. Part B says find the x-intercepts. Give me a second here. There we go. X-intercepts. I want to get it right so that you're like with me on the homework, right? So x-intercepts. I only have the one, and that is at negative 8. And they want just the x value. And then they say y-intercept. And that would be here at negative 1. Again, they just want the y value. Now, how would I find this? This is when the top is equal to 0. And so that would be x plus 8 is equal to 0. X is equal to negative 8. For this one, it's when you plug in 0. And so it would look like 0 plus 8 over 0 minus 8. And you can see that the 8's cancel, leave a negative 1. So these are not too hard here. But again, though, once you see it on the graphing, just go ahead and do that, okay? I'm doing it by hand only because I'm the teacher. So I know that sounds kind of bad, but oh well. Horizontal asymptote. It's a singular. And so what we're going to use are the 3 rules. We could probably get that from Desmos, but I'm going to go ahead and try it here, okay? So if you remember, there's 3 rules as to the degrees of the top and bottom. Well, notice that this is a 1 and this is a 1, so they're the same on both the top and bottom. That's rule number 2. So when the top degree is equal to the bottom degree. And that means that my horizontal asymptote is at the y equals the front fraction for this particular case. The front fraction, if you're looking back at our original, there's a 1 and a 1 here, an invisible 1. So 1 over 1 makes a 1. So 1, that's your answer for your horizontal asymptote. And let's just test it. So I'm going to say y equals 1. And yeah, you can see on the graph it kind of makes sense. That's where it's like going to. You can see it's not quite touching there, but it's getting close to it. So it looks good so far. Part E says find the vertical asymptotes. This is when, again, the bottom is equal to 0. We've already done this. It's at x equals -8. They want you to include the x equals... Oh, no, it's a positive 8. I'm sorry. Positive 8. They want you to include the x equals and the y equals on the past one because they want equations, okay? So we already did that one. Again, we already see it there. There you go. Now for the more calculus side of things. So they're going to ask for intervals of increasing and decreasing. Increasing, decreasing. And normally what we do is we're going to find my derivative and set it equal to 0, solve for x, and then we're going to kind of like use those as critical points. But if you look at how Desmos looks, what's going on is that this right here is going down. It's like really slowly going down, but then it goes down like whoosh. And then this right over here, this is going down as well. If you're going from left to right, as you read the numbers, it's going down. So everything's going down. The only place that it's not going down is this horizontal or this vertical asymptote. And so it's basically going down everywhere. All right. Let me see what I have for my notes, because apparently I crossed through something and, oh my goodness. Yeah, this is fine. This is going to be great. So let me show you what to do here. My increasing, when is it increasing? It's none. You're going to click the none button, basically. For decreasing, I'm going to say everything besides this positive 8. And I put this in here. And because they want it comma separated. And that is now the answer. Oh, it's so annoying. And that's what I put for my my notes. It said, annoying. Anyways, so it's decreasing on this side, the red, and it's decreasing over here as well, the red. So it's decreasing everywhere besides 8. Cool. Well, how would I do that by hand? I'm going to have to find the derivative. So my original is a fraction. And so I'm going to say my derivative is quotient rule. Low d high minus high d low divided by the square of what's below. So low d high minus high d low divided by the square of what's below. These x's are going to cancel. The 8's combined to make a -16. X minus 8 all squared. And this here, I'm going to look for critical points. Well, there's nothing in the top, but on the bottom, you can see x equals 8 is going to be one of those critical points. So we're going to carry that on to the next page now. So on my interval, I would be testing both sides of 8 to see if it's increasing or decreasing. Of course, we're going to be plugging it into f prime here. So f prime of, say, 7. 7's on this side. We're just testing 7. So I got -16 over 7 minus 8 all squared. -16 over, so that's a negative, but it's squared to make it positive. So we got a negative, which means decreasing. So this is decreasing. And then let's do f prime of 9. You're going to see the same thing, -16. 9 minus 8 squared, -16. It's a negative. Divided by 1 is again a negative. Again, this is going to be decreasing. So decreasing everywhere. Again, we already looked at the graph. We didn't need to have to do all that. What was that? Part F? A, B, C, D, E, F, G. Part G now says find the extrema. We already did this, basically. But this is when f prime is equal to 0, solve for x. In this particular case, I'm saying that this whole thing here equals 0. Now, we're looking for, whenever it says something is equal to 0, like this is equal to 0, you're looking at when the top is equal to 0. And that's never going to happen. Like, this part doesn't matter. I don't see how 16 can be 0 ever. So you're going to say there's no extrema. And what that is there's no critical points, there's no turning points, there's no maxes or mins, that kind of thing. Part H, we got concavity, concave up or concave down. So looking at the concavity of the graph, you can see that it's concave down right here, and here it's concave up. And so that's just my guess, is I'm going to say concave up is going to be from 8 to infinity. Concave down is going to be from negative infinity all the way to 8. Ding, 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 ding. We did it. We did it. I mean, it's not hard once you look at the graph. It's really not a big deal. So how do we do this, though? Like, what's the formula? This is when the second derivative is set equal to 0, and you solve for x, and you test the points around it. So going back, what we have for f prime is a negative 16 over x minus 8 all squared. But I can rewrite this so that it looks kind of like that. Notice that I have a negative 2 power now. So whenever I take my second derivative, the negative 2 will come down to the front. So I got a positive 32, leave the inside alone, and now it's a negative 3. If you rewrite it, it'll look more like this here. Cool. And so then I'm saying, hey, when is this one equal to 0? And again, this is more like the bottom or the top could be equal to 0. So here we got x is equal to 8 is one of those like critical, interesting places essentially. Just like here, we looked and saw the 8 from the derivative, okay? But then I had said no extrema. We're going to have a similar situation where we're looking here at 8, and it's going to be, a number line, and we're going to test around it. But then it's going to ask for the inflection points when it's actually, for reals, the top is equal to 0. And it's never going to happen. So I'm going to say none, because I'm going to say, hey, when is this equal to 0 for reals? And you don't got it. So just working ahead. So I need to test both sections. So I'm going to do the second derivative of 7. Do I already? Okay, I'll just go ahead and give you the answer. It's negative over here. And whenever I plug in a 9, let's say, I'm going to get a positive number. Because it's a cube, the sign from the bottom changes and affects it. So here we'll get a negative. There's a positive. Negative means concave down. Positive means concave up. And that's how I have my up and down answers. Inflection points, again, that's literally this thing is equal to 0, as in like the top is equal to 0. Solve for x, and there's none, and that's it. So then finally, part J, it says find the graph of this thing. And guess what? We already did it. It looks something kind of like this. Whoosh. Oh, that was a terrible whoosh. There we go, and there we go. I mean, just copy paste from over here. That's all. Okay, we did it. Whew, man. That was one problem. We got a lot more to go. So I'm hoping that you're seeing why I recommend Desmos graphing, because it'll do it all for you. It really will, and this is a good thing. It's 4, section 4. 34. Okay, so here's the next one. It has the same thing. And on my notes, I didn't do any like calculus with it. Like I didn't actually do any derivatives. I didn't solve for anything. I just did it. So here we go. And I wanted to do it with you. I mean, I could just say, well, just do the same thing. But I got to do some so I could show you the process a couple times. And look, I mean, it's an ln, so it's different than the last one. It's scary. I don't know what to do. I'm going to drink some coffee. It's pretty good coffee, actually. I always make my own coffee here at the house. It's great. Like not in a real coffee machine. I mean, who would use that, right? No, I use like the stovetop. Come on, bro. Old school. Anyways, so ln x squared plus 100. And it doesn't do such a great job of justice. I mean, what I want to do, and this is such a rare occasion. I would say don't do this like ever. But I want to show you so that I can kind of get a little bit better view of this thing, so that you're understanding what we're talking about a little bit better. Nope, that did not work. Okay, let me try again. Hold on. I think if I did -10 and 10 But then if I did here like -2 all the way to like, what are we going to do here? Like 10? Let's do 10. No? Not good enough. Let's go over here. Let's go 20 to 20. Is this better? I guess. It's just, it's kind of disappointing, but you can see that it's going to level off. You know what? I'm going to do one other thing. Hold on. Let's go pretty extreme here. So this is just, by the way, you can adjust the graph manually like I'm doing it. I don't see a lot of reason for you to do that right now, but I just wanted to do this so that you can see kind of like an extreme view. Okay, that's too extreme. Too extreme of a view, Chad. Okay, I guess. Yeah, that's fine. That looks a little bit better, okay? It's not to scale, of course, but you're getting the idea. Okay, and it's gonna. And I think what we're gonna see here is some good stuff. Okay, so you did not have to actually adjust it like I did. I'm not gonna like say, "Hey guys, adjust it every time." That would be silly. But I'm gonna make a point about it in this one. So part A, it says find the domain. And I'm looking at this thing. Again, I'm just going to use Desmos graphing as much as possible. It starts way over on the left side. It goes all the way to the right side. So negative infinity to positive infinity, and we're done. And it's so annoying. You have to click all real x values. Okay. Goodness me. X intercepts. So when is it ever crossing down here? None. Okay, part C, it says find the y-intercept. It's this guy right here. Did you see it? 4.6 blah, blah, blah. So, yeah, I went, so yeah, 4.60517, and I was like, oh, well, you know, I know they're going to want the exact answer. So you plug a 0 in, you still got 100, so you got like ln of 100. And they don't want that. They want the decimal. Oh, so annoying. Anyways, vertical asymptotes is when the bottom is equal to 0. I ain't got no bottom. I ain't got nothing like that. Look at my graph. Do I have a vertical asymptote? No. None. Part E says find the horizontal asymptote. Not plural, singular. Now, let's time out for a second, okay? Horizontal asymptote requires there to be a fraction where I have a polynomial in the top and one in the bottom. I don't have a fraction. I don't have a fraction here. So what's going on is I don't know. Like I have my 3 rules, but they don't apply in this case. So what do I do, right? Well, you look at the graph. In the graph, it looks like, oh, it's going up, and then it's going to stop, right? No, it's not going to stop. It actually just keeps going up. Do you see that? I mean, yeah, it's not going up as much, but it is still going up forever. It's going up forever. So is there a horizontal asymptote? I would say none, yet again. Okay? Again, we're looking at the graph to get our answers. Part F. We're looking for intervals of increasing or decreasing. Look at your graph. See how it's going down? And then it's going up. Where is it switching? Oh, yeah, at 0, at x equals 0. So here we go. Let's go. Increasing will be from 0 to infinity. Decreasing from negative infinity all the way to 0. There it is. We got it without doing any math. G. It says, does it have a minimum or does it have a maximum? And you're looking at the graph right here. That's a minimum. Whoop. I mean, like, this is not hard, guys. Especially when you're just looking at the graph. This is a good thing here, okay? We're looking at concave up and down. So if you see, this is going down, and this is also concave down. So I want to say, like, concave down everywhere. At least that's what I'm thinking. And I would be wrong. I would be wrong. Here's the thing. It looks like it's going down here. It's looking like that there. But there's something different about this. And let me zoom in to show you one more time. Do you see, like, looking right here? Doesn't that look like concave up? So where's the cutoff point between this side and that side? And if you just, like, click around, does it let me click? Is it going to do it? No? Sometimes they have inflection points you can just click. But yeah, it's not working. I can't click on it. It's somewhere around here. It's like changing from this up cup to this downhill thing, okay? So how do we do this one? Well, the goal is to get second derivative equal to 0, solve for x, that kind of thing. So let's start. My original was ln of x squared plus 100. My first derivative ln is 1 over stuff. And then the derivative of that stuff is 2x. So ultimately, I got 2x divided by x squared plus 100. My second derivative would then be quotient rule. Low d high minus high d low divided by the square of what's below. Let me start putting these things together. This is a 2x squared, and this is a 4x squared, so it's a negative 2x squared in the end. Here, when I distribute, I'll get a positive 200. And man, that looks so similar, doesn't it? Yeah, seriously, I could pull out a negative 2 out of the top. Actually, I don't think that's a good idea. Timeout. I'm just wanting to know when is this thing equal to 0. Like in the top, and that means the top is equal to 0. So let's just stop all that silliness and go right to solving the answer. I'm going to move this guy over so that I get 2x squared is equal to 200. Divide by the 2. Square root both sides. So I get square root of 100 is 10. So these are my inflection points. And they're going to be the answer for part I here in just a second. But essentially here at negative 10, let me see if I can kind of like get kind of close there. So look at what, not the numbers. Don't look at the numbers. Look at where I have this like bowl up versus the hill down. And it looks like this might be where it's transitioning. Like if you stare at it long enough, you can see it. Here's another one. There's the other guy. It looks kind of like that's where the transition point is from being a cup to a bowl to a hill. So yeah, cool. We got it. So how do I say that now? Like again, my graph. Well, I'm gonna just do this. It looks kind of like It looks kind of like this, and I'm looking at these inflection points. So this is up, and this is down, and this is down. Okay. So concave up would be from the negative 10 to 10. And then concave down are the other guys, negative infinity up to negative 10, comma separated. I'm going to verify on that. It's one of those annoying ones again. Yep, comma separated. I keep writing that because I'm used to doing unions. And there you go. Part I. Just as I expected, inflection points. And you're going to do x equals, and you put in a 10 and a negative 10. Cool. So we already had that. And then finally, part J says find the graph. Good thing we already got that as well. And then it does keep going up forever, so this graph isn't that great. But you know what to pick now. All right. Cool. So I have a note here. It says, many more, copy paste. So basically, I've already done 2 of them, and there's a lot more than 2 of them. And I'm sorry. I don't make this homework, man. I don't. So I have a businessy type one here, which we're going to do together. And then I have an 11-part problem. And we have another businessy problem, and then we're finally done. Yeah, so this one's at least a little better. So 11, 467. It says C of x, this is like my cost, is 40,000 plus 95x plus 0.04x squared. And it says find the oblique asymptote. The what? Did you just curse at me, Chad? You can go oblique yourself. Anyways, yeah, we're gonna find this thing, and there's another stipulation. It says find the oblique asymptote of the average cost function C bar. Ooh, they're just being mean. Okay, so yeah, there's a little bit more that we have to do. What is an oblique asymptote? So if you've seen it before at all, an oblique asymptote is synonymous. It's the same thing as a slant asymptote. So I don't know if you've... I can't spell asymptote, apparently. Good enough. Slant asymptote. Well, what this means, like if you're graphing something, you have like a dashed line that's like this, and normally you have a vertical one as well, and then you'll get some kind of graphs that do that. So they follow this. Try to not just make a thing messy there. They try to follow the slanty thing. Instead of it being horizontal, like normally we just have it straight horizontal, this time it's kind of like just a slanted line. That's what they're looking for here, okay? There's a very easy formula for this, and I'm just going to give you the Chad version because it is just that easy. It is division without remainder. Division without remainder. That's your formula for a slant or an oblique asymptote. So how does this work? Well, first off, we got C bar is going to be my original, the 14,000 95x 0.04x squared, but I'm dividing the whole thing by x. That's how you do the average. The average is saying divide by x, basically. So this is what we're going to do. Well, I said division without remainder. And look, see, isn't that a division? I'm saying now you have to do it. Like long division. And that would make you very sad because I'm totally not doing it correctly. Long division does not look like this at all. Like I need more here, and these are all flipped and stuff. Just, yeah. Long division's fine, but I recommend synthetic division. And this is very simple. You solve for x down here because there's no number beside it. It's just a 0. And 0 is kind of like your number, your pivot. I know we've done slant asymptote at some point. I'm sorry, not slant. Well, no. I know we've done synthetic division at some point. And we have to put these in order, obviously. 0 times anything is 0, plus the 95 is 95. 0 times anything is 0, plus this. Doesn't really matter. The reason why it doesn't matter is because it's without remainder. It's division without remainder. So I don't really care what's over here. This doesn't matter to me. This matters. And so I got y is equal to 0.04x plus 95. And that is the answer that they want. That's it. In fact, I think they want this because that's what I boxed in. Okay, so there's your slant asymptote. There's your formula for it, division without remainder. And you could do the long division, just that totally takes forever, and it's not worth your time right now. Okay, let's keep cruising. So we have 11,477. F of x is equal to x cubed plus 2x squared minus 15x. That's a 15 there. Divided by x squared minus 2x minus 3. Okay. They're wanting, on this one, it's not 10 parts. No, I'm sorry. It's 11 parts. Ah! Wow. More coffee, man. It's great coffee. Step 1, what do? You graph it. I believe that this one has the slant asymptote, and that's why I was doing it. because I want to make sure that I do some more of those with you. Yeah. Home? I'm going to click home. Oh, yeah, way better. Okay, cool. Yeah, if you need to ever, like, get everything back to defaults, you can just hit home. You're back home. So you can see what's going on. There's this slanted line that they're both trying to follow. And then there's a vertical asymptote also. And I don't really know what those are, but we're going to find those. Oh, what did I do? I did some removable discontinuity stuff. Oh my gosh. Okay. I don't know if that was a good thing or not. I'm just going to... Oh, man. Okay. Okay, let's chill out for a second, guys. Let's just chill out for a second. Okay. We're going to need to know a lot of stuff about this, and Desmos is great. It does a lot of stuff, but it doesn't do everything. So in order to get this more simplified for these next questions, what I want to do is factor this. I want to try to simplify this a little bit. In the top, what they all have in common is an x. And I promise you, this is actually the way you should be approaching this problem. Now, I think the top and bottom both have the ability to be factored. And so I'm looking at what two numbers multiply and add for both of them. Something like that. So multiply to 15, add up to a 2, 5 and 3. So then I would say a positive 5 and a negative 3. And here I'm multiplying to 3, but then going to 2. So that'd be a negative 3 and a positive 1. And notice that these guys cancel. Okay, so that's going to be a handy thing here in a few minutes. Now, it's still a hole in the domain, but it's a removable discontinuity. I'm just going to put removable. That's good enough, okay, removable. This is still also a hole in your domain, but so that's a 3. But it's not removable. This is a vertical asymptote. And we're going to get to all that later. What I wanted to do, because I know it's a slant asymptote right here, I wanted to just see what that slant asymptote is right now. And so what is remaining, I'm going to go and distribute this. What is remaining is this guy right here. And I want to do division without remainder. So I'm going to find the slant, the oblique, asymptote. Asymptote. Look, I'll even write oblique. Okay. The oblique or the slant asymptote. So I'm going to do division without remainder. And you can see we can do synthetic division once again. So that's going to be a negative 1 is kind of like my pivot. So negative 1. And then I have 1x squared, 5 regular x's, and then 0 numbers. So negative 1, 4, negative 4, doesn't matter. Again, my remainder does not matter. This is going to be my answer. So y equals 1x plus 4 is my slant asymptote. And I want to prove that. So what I'm going to do is say y equals 1x plus 4, just x plus 4 is fine. And you can see that, yep, that looks good. That looks like that's the line that they're going to be looking for. Okay, so now that we got all that, let's start with part A. So part A, I mean, we haven't even started the problem yet, guys. Domain. So I've already said this is when the bottom is equal to 0, and you got to look out for it with your holes. Well, notice we already did that here. Negative 1 and 3 are both holes, so I'm going to have to go around them. So negative infinity to negative 1. And look, I was trying to be good and do the whole comma separated thing. Again? Oh, it is so annoying. X not equal to, and you just simply put those two numbers in, you're done. It just never lets up. It never lets up, man. Always got to do something new every problem. X intercepts. This is when the top is equal to 0. If you go back, well, it's not going to be a 3, by the way, because that just canceled. It's these two guys. And so this is a 0, and this is a negative 5. But you can use Desmos for that. Not that one. I want the purple one. There you go. There you go. There's your two numbers, your X intercepts. So do still try to use Desmos whenever possible. I just don't think that would have helped you in this particular case. Part C says find the y-intercept, and that's right here at 0 again. If you got an x-intercept at 0, you definitely have a y-intercept at 0. There's no horizontal asymptote. You can see that there was just that slant. So I'm going to say there's no horizontal asymptote. You click that one. My vertical asymptote, we already talked about it, was x equals -1. Was it -1? Yeah, right here. See? Not this guy. That's just a whole removable discontinuity. I canceled them, but the thing that doesn't cancel, that's what we're keeping there. F is the oblique asymptote. I can't even spell oblique anymore. I don't care anymore. The slant asymptote, y is equal to 1x plus 4. Just go ahead and just put x plus 4. You don't have to put a 1 there, okay? There you go. All right. Keep cruising. Yep, this is what we're doing here. G, they're saying increasing, decreasing. So if you're looking at it from left to right, we're increasing. And then here, we're also going to be increasing. Here, oh, let's do the vertical asymptote. What was that? What, -1? Yeah, see. So that looks good too. So they're always increasing. But we got to avoid the removable discontinuity. And you know what's funny is if you hover on this and hit 3, you see that? You can't see it. And I know you're wanting to zoom in. You're like, hey, man, zoom in at 3. Bro, it's not there. It's just, look, see, there's nothing there. And yet, if you hover on it, it's there. Okay? You getting what I'm saying there? So it's still there. I have to watch out for that little chunk. Which is just annoying is what that is for no reason. But we're looking for when is it increasing, decreasing. So it's always increasing. As far as I'm concerned, it's always increasing. Yet, I have to go around the vertical asymptotes and stuff and the holes. So, comma separated. See, this is my domain because it's always increasing wherever there's any kind of domain. Decreasing, I would say none. So that one's easy. Part H says find the mins or the maxes. And again, I'm just looking, and I don't see any particular like hilltops or valleys. So again, none. I concave up and down. So concave up and down. If you look at it, if you zoom out here, it looks like it's concave up. And here it looks like it's concave down. And that's it. That's all I can say. So on the left side, it's going to be concave up. And on the right side, it's concave down. So I have to actually put the math. This one's easy. -infinity up to the -1. Because, again, that -1 is where we're transitioning. And so then -1 all the way to infinity. You forgot the hole at 3 again. You used the union. Last attempt. Pretty annoying. J, inflection points. And there's none. There's no transition. Like only this -1 vertical asymptote is doing anything, but that's not an inflection point. That's vertical asymptote. So you're just going to say none. And then finally, A, B, C, D, F, G, I, J, K. Oh my gosh. It says find the graph. And we already did it. So, taka, 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 taka. Ja, 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 ja. And there you go. Good enough. A, B, C, or D. You got it. Wow. We got one last problem. And you don't technically. I do. You don't. You have a lot. I mean, I do want to do a lot with you. But it is a lot of copy-paste. And most of it you can get from the graph. And you'll get better and better at the skills in order to like use the graph. Anyway, so we have a cost function changing according to how many units we sell. All that stuff. And so it says find the average. Well, you're gonna just take what you had. And you're gonna divide it by n. And There you go. You just did it. Yay. Okay. And now it says find the graph of your average cost function stuff. Yeah, Desmos for sure, man. We're going to do some Desmos. Hold on a second here. Okay. So. Oh no, why is it not working? Oh no. It's because you need to use X. Home. Zoom out. Got something around here? We got 1,080, so yeah. Oh, there we go. Ooh. Yes. Well, they're talking about like costs and stuff and number of units. Again, you don't have to do this, but I'm gonna do this. So let's do -1 all the way to like, I don't know, 100. I'm gonna do 100. That looks better. Look, that's good. That's good. And look, you can even see there's a minimum and all that kind of stuff. So it goes like whoosh whoosh and goes out there. Cool. So it looks kind of like this, honestly. And there's like a horizontal, I'm sorry, a slant, oblique asymptote there, but that's not the bigger point. Just what's the graph? And then part C, it says, what is the minimum? And you found it's right here, and it's going to be at 6 years, because apparently N is years or something. Thought it was units. I don't know. Anyways, it's whatever. So you just do 6, because you could see the answer 6. You could do the derivative, second derivative equals, or the first derivative equals 0. That's super easy also, but that's good enough. Okay, we did it. That was it. So thank you very much. Have a great day.